everybody. Hope you're all doing well. For the beginning of today's video, I just wanted to go over yesterday's homework. They looked very good, so I thought I would go through it just in case anyone had questions on a particular section. So if you feel you don't need to look at this part of the video, feel free to skip ahead a few minutes and watch the next part. So the first question I asked you was to find the roots or the zeros of this parabola. So we know to do that, we need to set the y equal to 0. Okay, I'm going to factor. This factors to be x minus 3, x plus 2. Let's tee it off. Set each factor equal to 0. So x equals 3 and x equals negative 2. So that's where this parabola crosses the x-axis, at x equals 3 and at x equals negative 2. To find the y-intercept, we plug 0 in for x. So we get y equals negative 6. So this parabola crosses through the y-axis at negative 6. Okay, formula for axis of symmetry is x equals negative b over 2a. Okay, so it's always good to take a look at what a and what b are. A is the number in front of the x squared, so a equals 1, and b is the number in front of the x, so b equals negative 1. So x equals negative b, so negative 1 is 1, over 2a, 2 times 1, so x equals 1/2. You can write it as x equals 0.5. Those are the same, so either way it doesn't matter, whichever way you want to write it, x equals 1/2 or x equals 0.5. That's where the parabola is cut in half. Okay, and now let's do the vertex. So to find the vertex algebraically, we need to take what we got for the axis of symmetry, x equals 0.5, and we need to plug that in for x. So we had our equation, y equals x squared minus x minus 6. So let's plug in 0.5. And when we do that, we get y equals negative 6.25. The very last step is to write it as an ordered pair, so 0.5 comma negative 6.25. That's the turning point of this vertex. Okay, so now let's go to the next question. This is a regions question. It's a word problem, so let's read it through and we'll do it together. So it says, Alex launched a ball into the air. The height of the ball can be represented by the equation h equals negative 8t squared plus 40t plus 5. So right away, I know that this is going to look like a parabola because it has an x squared. Actually, it has a t squared, but same thing. H is the height in units and t is the time in seconds after the ball was launched. Now, they specifically want us to graph from t equals 0 to t equals 5. Okay, now we're going to use our calculator to help us do this. I have this parabola. They want me to graph from 0 to 5. Whenever they ask you to graph anything, we're really going to go into our calculator. So what I'm going to do before I go, I'm going to show you my calculator, is I'm going to start making a chart because I want to graph when t is 0 all the way to when t is 5. So if you could take out your calculator, that would be great. I already plugged it into my y1, so I'll give you a second to do that. We're going to use x instead of t. So negative 8x squared, the x is right below the green button, plus 40x plus 5. Okay. Now when you go to graph, your graph probably looks like this. And that's okay. That's what it should look like. It should look something like that. We're going to change our window a little bit. And I believe we talked about window before in class, but we haven't talked about it that much. So the window is going to allow you to see more or less of the graph. More or less to the right, more or less to the left, up or down. So I always ask myself, well, what do I want to see more of? In this case, I want to see more up. I want to see more of the higher y values because it gets cut off. So let's go to window, and I want to go to y max, and I'm going to start at 50 and go to graph. Looks better, but still not enough. I didn't go high enough on the y's. So maybe I'll go back, and it's, you could kind of play around with it if you want. I'm going to do 100, and that looks pretty good. So now I can see my whole graph. It certainly does look like a parabola. So now what I'm really interested in is I'm interested in the table because I want to graph these points. So let's go to the table. Second graph brings you to the table. And I'm interested in 0 to 5 because that's what the question asked me. So 0, 5, 1, 37. So I'm going to start filling these in. Just so I don't have to keep switching back and forth. 253, 353. If you want to just use your table, you don't need to write it down. I'm just writing it down, that way I can graph it all at once. So 4 is 37 and 5 is 5. Okay. So now we need to set up our scale for the x-axis and for the y-axis. So x time in seconds, that's going to be the 0 to 5 that they asked me to graph. So that one I can set up. I have a lot of boxes. It doesn't matter. What I'm going to do is I'm going to do every other box and I'm going to make it a new one. So 1, then I'm going to skip a box, 2, then 3, then 4, then 5. I'll even label a 0. Okay, now I need to go up to at least 53 for the y's. So I'm going to go up each box by 5s. That seems to be a good scale that I picked. I didn't totally go up to the top, but I had a little extra room, so that's good. All right, so let's graph this parabola. So 0, 5, 137, so that's between the 35 and the 40, 253, so that's between the 50 and the 55, 353, 437, and 5, 5. Okay. So now I'm going to connect these only from 0 to 5. So we know the parabolas curve up at the top. So I'm going to curve it a little bit up there, and I'm going to stop right there because they're telling me to stop at exactly 5 seconds. Okay, so notice I'm going to highlight. You don't need to highlight, but at the top of the parabola, the vertex, I just want you to note that I did kind of make it curved. I don't know exactly what that top point is, but every parabola has that curve at the top, so I made it curvy at the top. Okay, so that's so far so good. And then it says state the coordinates of the vertex and explain its meaning in the context of the problem. Okay. Well, we know how we need to find the vertex. To find the vertex, it's really a two-step process. We find the axis of symmetry, and then we find the y value that goes along with it. So the axis of symmetry, x equals negative b over 2a. So A is negative 8 and B is 40. So x equals negative b, so negative 40 over 2a, so 2 times negative 8. Okay, so why don't you put that into your calculator, negative 40 over 2 times negative 8. Negative 40. I can't make the fraction like you can. So I get 2.5. So x equals 2.5. Okay. All right. So now the next step is to plug in that y value. So y equals, well, the original problem is negative 8t squared, so I'm going to plug in 2.5 every time I see x, or really t, plus 40 times 2.5 plus 5. Why don't you pop that into your calculator? I got 55. Y equals 55. So the coordinates are 2.5 comma 55. So that's my answer. Let's see if that makes sense. So if I look, does my graph seem to be cut in half? At 2.5. Yeah, it absolutely does seem to be cut in half at 2.5. And is 2.5 comma 55 seem to be a good, yeah. Maybe when I personally, when I graphed it, maybe I went a little too high, but that looks good. That looks like that could be the point. Okay, and then let's explain its meaning in the context of the problem. So x is time, so 2.5 is time. Maybe let's make ourselves a little note of that. So that's time, and y is height. Okay, so at 2.5 seconds, the ball is at a height of 55 feet. And I'm even going to say reaches its max height of 55 feet. And the reason I'm saying max height or maximum height is because we know that the vertex or the turning point is the highest in this case the graph will be. So at 2.5 seconds, the ball is at its maximum height, which is 55 feet. Okay. There is one more question. I'm going to leave you to do it on your own. It's similar to the one up above where you have to use your calculator. So use your calculator, get your points, and then I want you to figure out, they're just asking you for the equation of the axis of symmetry here. Okay, everyone, I'll talk to you soon. Bye.